My name is Matt Kaar. I'm a team lead and cyber exercise developer in the Cyber Workforce Development Directorate at the Software Engineering Institute. Last year, we were asked by the Cybersecurity and Infrastructure Security Agency, or CISA for short, to plan, execute, and support the first ever President's Cup cybersecurity competition. In this presentation, I'll walk through the history of the competition and give a demonstration of the platforms used to deliver the event. Finally, I'll talk about the benefits of this competition to the Department of Defense. First, what is the purpose of the President's Cup? Established by Executive Order 13870, the competition is designed to reward the best and brightest talent in the federal executive workforce. To cast the net as wide as possible, the President's Cup employs a set of online qualification rounds available to anyone with a .gov or .mil email address. Internet access and a modern web browser are the only system requirements for competing in the President's Cup. Creating a common playing field is crucial to the mission of finding the best talent, regardless of his or her computing resources. Using the National Initiative for Cybersecurity Education, or NICE, framework as a blueprint for challenge development, competitors face a variety of challenges across different cyber work roles and job tasks. This helps make the competition more relevant for the federal workforce, focusing on challenge tasks that they might find in the course of their current cybersecurity job. And by highlighting the cybersecurity workforce at the federal level, the competition hopes to put a dent in the 500,000 cybersecurity job vacancies across public and private sectors in the United States. Addressing this shortfall is one of the ultimate goals of the competition and is part of a multi-pronged approach by CISA to address this talent gap in the federal government and beyond. Switching gears to last year's inaugural competition, the first year's President's Cup was a whirlwind effort. The SEI was given approval to execute the competition in late July 2019, and the executive order required winners to be selected by the end of the calendar year. In that time, SEI developed a novel web-based competition platform, authored 82 technical challenges, and designed a 3D escape room video game for the finals that concluded on December 14th with a YouTube live stream event. For this year's President's Cup, we made many improvements, including designing separate tracks for the individuals competition, implementing partial credit challenges, making 2019 challenge content available on a number of platforms, including GitHub and YouTube, and partnering with CMU's Entertainment Technology Center to design a new video game experience that will debut at the finals this year. And before we start the demo, I'd like to recognize the 67 contributors across the Software Engineering Institute and the greater Carnegie Mellon University community that have contributed towards President's Cup success over the past 2 years. From challenge development to platform development, to support, to broadcast media, it takes a team effort to make this complex endeavor a reality. And now, on with the demo.
The President's Cup 2020 is coming. Prove that you have what it takes by competing as a team or individual or both. Registration opens July 27th. The team competition kicks off August 10th and includes challenges across the entire cybersecurity spectrum. Starting August 24th, the solo competition is split into Track A and Track B. Participants can compete in one or both tracks. All qualifying rounds will be remote participation. For more information, visit CISA.gov/President's Cup. Come prove you are the best cybersecurity professional defending our nation.
That video provides a nice overview of the competition. This is the competition landing page, located at presidentscup.cisa.gov. You see there's a New for 2020 section, Media Assets, Competition Rules, and Frequently Asked Questions that our support staff use regularly. We actually host the source code for the page up on GitHub, so we can easily make changes alongside our sponsor. With that, this is our launching point for the rest of the demo. We're going to go through these buttons and show off the different areas of the competition. First, we'll open the Teams competition. But before we can access the Teams site, we'll need to log into the President's Cup identity server. This is an open source SEI application, also available on GitHub, and provides the authentication mechanism for cyber workforce development's modern web apps. After we're logged in, let's take a look at the Round 2 leaderboard. We'll zoom in on the current leading team, and I want to point out the addition of partial credit challenges this year. We added the ability to earn partial credit based on feedback from last year's President's Cup. You can see this team received full credit for over half the Round 2 challenges and earned partial credit on 3 more of them. Now, because I have observer status on the game board, I can take a look at how competitors are solving challenges in real time. This is valuable to get a sense of technique, as well as see how quickly challenges are solved. This competitor is using Wireshark to analyze a packet capture for a Teams round challenge. We believe detailed analysis of these solve videos are valuable from a research perspective. Now let's take a step back to the landing page again and look at each of the individual tracks this year. As the kickoff video mentioned, individuals Track A includes incident response, and Track B includes exploitation challenges. We thought that this would separate competitors based on their respective skill sets, but it turns out that over half of individuals who qualified for Round 2 in Track A also qualified for Track B. Now, as we make our way over to Track B, you may also notice there are a number of perfect scores atop the Track B leaderboard. We're increasing the difficulty in Round 2 to ensure we don't have a repeat of that. Now let's move to the 2020 practice board. This board allows anyone with a .gov or .mil email address to log in and complete practice challenges. And we encourage all competitors to do so. The challenge I'm highlighting was written to show off what we call infinity challenges. Challenges where the correct answer is generated at launch time. When the challenge launches, a script determines the correct answer and populates a virtual environment with the means to find that answer. Each challenge includes instructions to get started, along with a link to any virtual machines deployed for the challenge. This particular challenge launches 20 Docker containers, each running a web server. You'll see those containers come up when I type in the docker ps command. Now, each containerized web server responds with a 6-digit number. The simple goal of this challenge is to provide the sum of all of those container numbers. Jeff Matson, a developer on our team, loves these bash one-liners, and he created a slick one-liner to solve this challenge with a minimal amount of typing. We're going to use the copy-paste functionality within the console viewer to paste in that one-liner to solve the challenge. Now that we have the answer, we're going to use copy-paste again to get that answer out of the virtual machine and into the submission box. Bear in mind, I only have 3 attempts to answer this challenge, and that's done by design to limit guessing. After I submit the answer, it shows I received full credit. And now I'm going to rate the challenge as easy, but also excellent. And I can provide some free text feedback as well. That competitor feedback is available to moderators within the application. We also provide the same feedback to our government sponsor. And now that we've taken a look from the competitor's point of view, let's switch gears and see how the challenge is developed. Here's the interface that challenge developers use to author documentation, as well as provide correct answers for each challenge. As we scroll down, you see the documentation authored in Markdown format. And the right side provides a preview of what the competitor will see. At the bottom, we have the opportunity to create different variants of the challenge. In our case, we just have one variant because it's being generated dynamically. Here we define a script, and that script runs inside of a Docker container. As a result, we have a lot of flexibility when generating the solution to this challenge. This is the script that executes when the challenge deploys. It creates some random numbers using a seed value, and that seed gets passed into a virtual machine inside the challenge's namespace. To build the virtual machine templates, we use a separate web app called Topo Mojo. Like the others, this app is open sourced on GitHub. Inside the virtual machine, I'm going to show off a few Ansible playbooks that populate the Kali Linux VM with the containers you saw earlier. This playbook generates the same random numbers from the seed in the previous script. And this next playbook creates a container serving out each random number. So that's a walkthrough of what's happening on the back end, the workflow that our challenge developers use when they create each challenge. From there, we'll head to the President's Cup archive site, which contains hosted versions of last year's challenges and allows competitors to solve them using only a web browser. I've deployed challenges using my iPad, and they work great. The site gives each user 4 hours to complete as many challenges as they want, and they can reset each board as many times as they want. Each round from the 2019 competition is represented on the respective board. One of the unique things about this environment is that all the virtual machines deploy to a VMware cluster running in an Amazon Web Services data center. While the web applications you've seen are already containerized and running in the cloud, our sponsor asked us to move hypervisor workflows in that same direction. This is a first step towards having President's Cup running completely in the cloud. Now let's head to GitHub, where we've published open source code for over half of the 2019 challenges. For any challenge that's eligible to be open sourced from a licensing perspective, we published the source code before the 2020 competition started. This includes solution guides for each challenge. This gave 2020 participants an opportunity to learn from last year's competition, whether or not they participated. And this will be the pattern going forward. Every challenge we can open source becomes a learning tool after the competition ends. Finally, the last stop on our tour is YouTube. With the help of our broadcast media team and challenge developers, we developed walkthrough videos for over half of last year's challenges. As you heard, each one has a catchy soundtrack and provides text prompts that accompany the screen capture video. Where it makes sense, we provided links to the corresponding GitHub page for challenges that have both source code and a video walkthrough. And with that, we're back to our starting point. This concludes my demonstration of the 2020 President's Cup. Thanks for your attention. Now, after watching the demo, you may be asking yourself, how does this apply to the Department of Defense? Well, the DoD contributes more participants to the President's Cup than any other top-level department or agency. But aside from that fact, there are other benefits to the department. As part of the SEI's continued support to the DoD, we understand their interest in the quantitative assessment of cyber operators and teams. Quantitative measures of success are valuable in deciding which teams should be declared mission-ready and which teams require more training to get there. The open-source platform hosting the President's Cup competition provides a unique take on large-scale assessment of these cyber teams. Through repeatable deployments of virtual machine environments that vary in scale and complexity, cyber teams can be presented with a mission and evaluated on the techniques employed to complete that mission. Further, these scenarios can be presented in rapid succession, evaluating teams on their relative efficiency in completing all the scenarios encountered. For the President's Cup, teams have 8 hours to complete as many challenges as possible. A similar time limit can be employed for DoD cyber teams to work through various mission readiness scenarios by having well-defined measures of success and accurately measuring goal completion inside each virtual environment. The time to complete each task and ultimately each scenario can be measured and compared between teams. And while time provides one dimension for measuring team performance, it's hardly the only measure or even the best one. How a scenario is completed provides a potentially richer data set for analysis. Using the platform's observation mode, each team's technique can be visually recorded and compared against other participating teams. And while comparing cyber techniques used to achieve a mission objective is more involved than comparing the time taken to achieve that same objective, artificial intelligence and machine learning models for a given scenario allow those comparisons to be performed at scale. In turn, this level of analysis can provide quantitative views into the decision-making and behavior of top-performing cyber teams. To conclude, in this presentation, we discussed the history of the President's Cup, provided a behind-the-scenes look at how the competition is built and executed, and offered potential research opportunities for the assessment of cyber teams at the Department of Defense. For more information about the President's Cup, you can contact me at info@sei.cmu.edu. Thanks for your time.